This facility receives mixed scrap copper collected from demolition, electrical upgrades, and industrial surplus. A rotating grapple collects and transfers loose scrap into the processing hopper. Hydraulic lift systems unload bulk scrap into reinforced intake zones. The apron feeder controls how much scrap enters the system at one time. Manual sorting removes non-copper contaminants before shredding. Magnetic drums extract steel while copper passes through. The next stage reduces large copper scrap into smaller fragments. Hardened cutting shafts tear through thick copper sections. Shredded copper fragments exit onto the transfer conveyor. From bulk scrap to shredded fragments, the transformation has begun. After shredding, the copper fragments move into a controlled separation building. A vibrating table spreads the shredded copper for consistent processing. Air density separation removes lighter contaminants from heavier copper.
Extracted light waste is collected separately in a sealed bin.
Rotating trommel screens separate copper by particle size. Uniform particle size ensures stable melting in the furnace. Water separation uses density differences to isolate pure copper. Heated air removes residual moisture from the copper granules. Clean, dry copper granules are prepared for furnace melting. Purified copper granules are now moved toward the smelting furnace for melting. Copper is introduced in controlled batches to maintain temperature stability. Once fully molten, impurities rise to the surface as slag. The molten copper is transferred into a ladle for continuous casting. Molten copper enters a tundish system that control the flow into casting molds.
High-pressure water spray nozzles mounted along a steel manifold direct streams of water onto the descending copper billet.
Motorized rollers pull the solidifying copper billet at a controlled rate. Once cast and cut, the billets are staged for the rolling mill. Continuous casting transforms molten copper into solid billet form, ready for mechanical deformation in the rolling mill. Before rolling, the solid copper billets are reheated to increase ductility.
Camera repositions near the third rolling stand where automated guide rollers align the heated copper rod, glowing reddish-orange elongated metal.
Cooling stabilizes the copper rod after deformation. The laying head coils the rod in uniform loops for cooling. Formed into compact coils. Rotating steel brushes remove oxidation formed during hot rolling.
As the continuous copper rod emerges from the acid bath, it immediately passes through a rinsing station.
Drying prevents corrosion before the drawing process. The copper rod enters the multi-stage wire drawing line where diameter reduction begins. The partially reduced copper wire, thinner reddish metal conductor compared to the original rod, passes through a lubricant. Wire diameter is reduced gradually through multiple drawing dies. The final die defines the precise diameter of the copper conductor.
Cold drawing increases strength but reduces flexibility, so the copper wire must be annealed.
Controlled cooling stabilizes the wire's internal structure.
The annealed copper wire passes over load cell rollers connected to a digital control module that adjusts downstream motor speed.
Electrical resistance is measured to confirm conductivity targets. The annealed copper wire travels through the tunnel supported by ceramic rollers, because moisture removal prevents corrosion before insulation. After annealing, the bare copper conductor enters the insulation extrusion line.
Small cylindrical PVC pellets feed downward by gravity into the rotating screw inside the heated barrel, where
Molten PVC is extruded concentrically around the moving copper conductor. Laser sensors verify the outer diameter of the insulated wire. High-voltage spark testing detects microscopic insulation defects. Because accurate length measurement ensures compliance with product labeling standards. Sample sections are cut to verify conductor and insulation dimensions. Retail spools are wound under controlled tension to prevent kinks.
Continuity testing confirms that the conductor remains electrically intact.
Barcode scanning verifies product and batch information before sealing.
Each pallet is logged into the warehouse management system for real-time tracking.
Pallets are transferred directly from storage racks to transport trucks.
Seems to be in order.
From the manufacturing warehouse, insulated copper wire moves to regional distribution centers.
Electrical supply stores stock various gauges for residential and commercial use.
The total for the copper wire is $125. Will this be on your contractor account today?
Yes, thank you.
The insulated copper wire is routed through structural framing during installation.
Proper terminal tightening ensures safe electrical conductivity. Recycled copper now powers real-world electrical systems.